Good morning, my YouTube viewers. Crystal here. This is the first video that I'm making for 2021, and what I'm going to do is I'm going to compare the Taiwan and the Chinese rates of infection, because Taiwan is just a little island on the outskirts of mainland China, and mainland China says that Taiwan is part of mainland China, but Taiwan says no, they're their own country. And Taiwan is actually on the data set that I've been using to compare COV19 statistics, but the World Health Organization does not recognize Taiwan, and they do not communicate with Taiwan. But fortunately, other people do recognize Taiwan and communicate with them. And so Taiwan is a democratic nation, and it's just a little small island. So I thought that since China claims Taiwan and says Taiwan is part of China, and the World Health Organization refuses to communicate with Taiwan and to even discuss Taiwan, I thought it'd be a good idea to compare the COV19 statistics to the Taiwan statistics and see what we can find. And it's very interesting indeed. So the first thing that I did was I used this data set that I get from our World in Data. Now that data set is updated daily. So if you're going to use that data set, then you have to load that data set onto your system, the most current version, onto your system every day. Because if you don't load it onto your system every day, you're not going to be working with the most current version. And yesterday we had a little problem because Bulgaria, yesterday was New Year's Eve, and Bulgaria had actually entered New Year's Eve on the data set before they'd even collected the data. And this obviously caused problems to me when I was working on the data set. So I had to sort of modify the program to try to get around what Bulgaria had done. And this morning I did some more work on the program as well. And so you will see the work that I've done on the program in addition to that. So that's a good idea. So I wrote the program in Google Colab. The reason why is because Google Colab is an online Jupyter notebook, and it has most of the libraries that you're going to need already installed on it. Some of the more obscure libraries are not installed, but the libraries that are, mainstream Python will be installed. So I imported pandas and NumPy because those are the two main libraries that you're going to need. And I'm going to be doing some more studies on pandas and NumPys and see if I can do an analysis just using pandas and NumPy. But you also need Matplotlib, because Matplotlib allows you to plot graphs and things like that. And people want to see graphs. So maybe I'll make it pandas, NumPy, and Matplotlib and just do an analysis that way, and just to show people all of the different codes and things you can use with these three libraries. We loaded the data set. I'm using the most current data set because I checked it this morning. It had been updated, so I loaded it up. We're working with the most current data set. I wanted to see what kind of information was in the file. Most of the columns are float, but we do have a few objects. Okay, so what we had to do now is what we were going to do is we're going to convert the date to a number. So you have import date time, date equals train.date, train date equals PD to date time, train date errors equals coerce, train date num equals train date, DT STRF time, and then train. So In that aspect, we have converted the date to a number, and we converted the date to actual. First thing we did was we converted the date to date time, and then we converted the date time to a number. So you can see all the dates are numbers now, which is what we want to see and what we're going to be using. So we wanted to see how many countries this data set is collecting statistics on. And so I put a little code in there. So country equals train location to list. So I created a list. List is blank, list is empty. And then you go through for I in country. If I not in list country, append I. So if that country is not in the list, then they will append the country to the list. And then we printed it out. We've got 192 countries. And what I will say is that now whenever I'm doing my analysis and stuff, there's only 191 countries. So somehow or other, one of the countries dropped off, and I don't know why that is, but it did. So you can see here it says it's got 109 countries. So now what we have to do is we have to get the latest date. And then because of what Bulgaria did, and this happened yesterday, yesterday was December 31st. So yesterday, Bulgaria put December 31st in there. And because when they hadn't recorded any statistics, because December 31st hadn't ended. And so what I had to do was I had to do a little bit of coding to try to get the most accurate data set. But now what I did was I did some more coding, and I'll go over that with you. So we have to import date and time delta from date time. So today equals date dot today, print today. So today is January 1st, 2021. Yesterday is today minus time delta, days equals 1, print yesterday. Yesterday was 31st December 2020. Last date equals train date max, and so you can print last date, and it's a timestamp of 31 December 2020. So it says you print the type that last date was, and so that's a timestamp. Now, yesterday equals PD timestamp yesterday. So what we're doing is we're putting a timestamp on yesterday. And print type yesterday, and it's saying that yesterday is a timestamp, which is what we want. Now, so next day equals yesterday plus time delta days equals 1, print next day. So next day is going to be 1st January 2021. So next day is really today. So now what we had to do is we had to use an if statement. If last date equals yesterday, last date equals yesterday. Else if last date is greater than yesterday, last date equals yesterday. Else last date equals last date. So what we did there is I think that we're trying to overcome that business with what Bulgaria did, entering the date without putting any statistics in there. So hopefully it'll work. If it doesn't work, we'll soon find out the next time something like that happens. So now we want to see the last date. Last date equals train. Train date equals last date. So we're going to see last date. And so you can see the last date is 31 December 2020. Now we're going to graph it. So we're graphing the new cases. We graph the new deaths. And what we're doing now is we're graphing, making a location, the new cases on the location. And we're doing the new deaths on the location. The next thing we want to do is we're making a box plot on the continent so you can see North America has the most new cases. So we're doing a box plot on the new deaths, and North America has the most new deaths, with South America having quite a few as well. And now what we have is we have a heat map. So if you like heat maps and you want to see how all of the different independent variables relate to each other, then certainly you can find that out by looking at the heat map. So now what we want to do is we want to use the UK. So we put a filter on the UK. So now we've got all of the UK data. So you can see the UK new cases per million, and you can see that it's just creeping up there. They're trying to contain it, which is why we're now in tier 4. And you've got the UK new deaths per million, and you can see that that's creeping up there as well. It's almost as high as it originally was when they first had the pandemic in March and April. Now we put a filter in so we can check the United States, so you can see the United States. So we've got the United States new cases per million, and you can see that the new cases per million are creeping up there. The new deaths per million, you can see that the new deaths per million are creeping up there too. So now let's look at China, because China is what we're going to be looking at. You got the China new cases per million, and you can see that they had initial spike, and now they don't have any more. I don't know exactly why they don't have any more new cases. Can't say. And then they got the new deaths per million. So they had an initial spike, and then it's gone down again. So this is what I just heard by watching a YouTube video, is that what China does is when someone dies and they have COV19, then what they'll do is they'll put the secondary illness on the death certificate. So if they had heart disease, they'll say they died of heart disease. Or if they had diabetes, they'll say they died of diabetes. So they'll put on the death certificate that they died of the secondary illness, which is why the deaths are so low compared to the UK and other countries. Now we're checking Taiwan, and so you can see Taiwan. And Taiwan started taking records, keeping records before China did. They started keeping records on January 16th, 2020. So Taiwan was very aware of what was going on with China. And so now we've got Taiwan new cases per million. So this is all their new cases. And this is Taiwan new deaths per million. And I'm not sure exactly why that is. I don't know if it is because they are recording the secondary cause of death on the death certificate. I'm not sure exactly why that is. So now we've got South Africa. We've got South Africa new cases per million, and you can see that's creeping up there. And the reason why is because in South Africa and also the United Kingdom, they have a new strain of COV19 that is more infectious than the original strain. So that's why the cases are creeping up there. So now we're looking at new deaths per million, and you can see that the new deaths per million are creeping up there as well, and that's most likely to do with this new strain that is more infectious than the original strain. Now we're checking Sweden. We checked Sweden because they didn't go into lockdown But what I think I'm going to do tomorrow is I'm going to compare Sweden to Denmark, which is a neighboring country, and we'll see what it looks like for a country that had no intervention compared to a country that had very swift intervention. And we'll look at those statistics as well. So you can see Sweden, it's just the new cases are going up there, and I think it's because they're so close to the UK, and we've got this new virulent strain of the virus coming out of UK. And since Sweden is a European country, it's probably easier for this new virulent strain to get to Sweden than it was a lot of places. So I suspect that's why Sweden's new cases are increasing, and Sweden's new deaths per million are increasing as well. And even I was watching a YouTube video, and the King of Sweden said that he made a mistake when he didn't go into lockdown because the number of deaths was unacceptable. And it's a real touchy subject because obviously, well, the king is a king, but like in these democratic societies where we elect our officials to look after our best interests, then, we're electing these people to keep us alive. But I know the king wasn't elected. So it's a tricky situation. So in a democratic country, when you elect an official, you can go to that official and say, well, we want you to vote this way because you're supposed to be representing our interests. But a monarch should be representing the interests of the people, but they're not necessarily representing the interests of the people all the time. And I don't know how much influence the king had in instituting a lockdown, but he did actually say that it was a mistake not to institute a lockdown. And you can see here that they do have a lot of cases per million. So now what we're going to do is, this is globally, we are comparing the new cases to the deaths. And then with the United States, we're comparing the new cases to the deaths. And with the UK, we're comparing the new cases to the deaths. So now what we're going to do is we're going to compare the countries. So what we had to do was we had to clip off some rows from the data sets to make sure that all the data sets had the same number of rows. Because if the data sets didn't have the same number of rows, it wouldn't work. So we clipped off 7 rows off of UK. We clipped off 16 rows off of US. We clipped off 16 rows off of China. We clipped off 22 rows off of Taiwan. So Taiwan started taking records before anybody else. We clipped off 6 rows off of Sweden. And now what we're doing is we have to create data frames for all of these countries. And that's what we have to do. So date is revised UK COV19 date.values. It has to say values on it, because if you don't put values on it, then it's not going to work. So always on the date, it has to say values. So we created variables for the UK, the US, China, Taiwan, South Africa, Sweden. And then so what we've done is we've created a new data frame for the UK, the US, China, Taiwan, South Africa, Sweden. And now what we've done is we've merged all of those data sets together. And so you can see that all of these data sets have been merged together. But the thing about merge is you're only allowed to merge 2 data sets at a time. So that's why it's such a long string of code. So we wanted to check to see if we had any null characters in this new data set, and we did, but all of the null characters are in numeric columns. So we just did a blanket fill in A with compare. So we didn't have to do any ordinal encoding or anything like that because it's all numeric. So we just said fill in A with 0. So now what we're doing is we're comparing the Taiwan with China. And so you can see that China had an initial spike, and then it had an initial spike, and then it tapered down to almost nothing. And then Taiwan had a small spike, and then it tapered down, and they got some more new cases. And the same thing happened with the new deaths. With China, they had an initial spike of deaths, and then it tapered down to almost nothing. And then Taiwan had a few spikes, and it's tapered down to almost nothing. But what I wanted to do, so basically, it's real difficult to compare the two because both of these countries have such low levels of infection and low levels of death. So I wanted to compare them to the UK and see how they compare to the UK. And so you can see the UK's way up there. We're creeping up there. We're trying to get it under control. And then there's Taiwan and China. And these are the number of deaths. The deaths are going up. We're trying to keep it under control. And these are the number of deaths. So now that completes the analysis. But what we're going to do is we're going to go ahead and finish the program. So we checked for our null values, had loads of null values. So what we have to do is we have to impute these null values. So what we did was we dropped the date, so it doesn't need the date. And then we we did a search on all of the values that are not numeric. And so we found all of the columns that are object files. And we imputed all of the columns that were object files as not listed. So I just created an extra category called not listed. Because rather than using the mode, I mean, why are you going to use the mode? Because we don't know what the value was. And so then what happens is you're just left with numeric values. And so since you're left with numeric values, what we did was we just filled everything with 0 that was a null. And now we're going to take all of these object columns and we're going to put them onto an ordinal encoder and ordinal encode them. So that makes them numeric values because that's what the model wants to see. The model wants to see numeric values. So now what we're going to do is we're going to define X and Y. So Y is train new deaths. We're just looking at the new deaths. And X is train drop. And you've got lots of columns that we're going to be dropping. And you can look at that. Now we're putting X on a standard scalar. So you can see Y and you can see X, which is an array that has been scaled. So now we're going to split the training file up for training and validation. And now we select the model, and we decided to use HIS gradient boosting regressor because that model is designed for large data sets, and we're working with a large data set. And we've got a 99.44% accuracy when we trained and fitted the model. And now what we're doing is we're predicting on the validation set, and we've got an 88.32% accuracy when we predicted on the validation set. So you can see your Y val, and you can see your Y train values, and you can see Y pred. And then we put this on a little chart, and the chart doesn't look very good. But you can see that we've compared the Y val with the Y thread, and you can see that. So we put our predictions on a data frame so you can compare the actual deaths with the predicted deaths. And we have created a new test data set. So test equals last day copy, test date equals next day test. So basically what we've done is we're checking everything for January 1st, 2021. So, but you can see, you can come over here to date num and you can see that date num hasn't been changed. So what we have to do is we have to convert the date to a number. So test date num equals test date dt strf time, the format, and then test. So we come over here so we can see today's date, January 1st, 2021, and you come over here to date num and it's January 1st, 2021. So the values are the same. So now what we do is we check it for any null values, just like we did on the trained data set. Got loads of null values. So what we do is we impute the missing values. So predict date equals test date, test equals test drop date. And then so we find all of the object columns and we impute those object columns by any values that are null. We just put the word that says not listed in there to create an extra class. Because I just thought about it and I thought, well, why are we going to use the mode value? Because we don't know what the value is. And so it's better just to say not listed. Because anytime you have missing value, then it's going to affect your readings. So we've got now we're going to impute the numeric values with 0. So we can do that throughout the whole data set. And now you can look at your test data set. Now what we've done is we've ordinal encoded all of our object columns to make them numeric. And now what we do is we define our X test. And then so ISO code equals test on ISO code. And then so X test, and we drop loads of columns. The columns that we drop on X test were the same as the columns that we drop on X. We put X test on a standard scalar. And now we predict on the test set, the same as we did on the validation set. We put our predictions on a data frame. So these are our predictions. So what you can do is tomorrow, if you wanted to, you could compare the predictions with what actually transpired. So that basically concludes this code review. I hope you got something out of it. If you like my video, please like, subscribe, and share. And if you like the work I do and would like to make a donation, I've got my email address to my PayPal account in the description box down below. I have to ask for donations because I don't have enough subscribers and I can't monetize. So thank you so much for watching my video, and I look forward to making new videos for you in the future.